Hello, my name is Mark Tomerdahl. I am president and co-founder of CorticalMetrics, and today we'd like to give you an overview of CorticalMetrics and the brain gauge. And our goal at CorticalMetrics, the company, is to develop the best way to measure brain health that is not only very sensitive to changes in brain function, but is affordable and easy to use. So what is the brain gauge and what are cortical metrics? Cortical metrics are the measures obtained with the brain gauge. And the brain gauge is the tactile stimulator that interfaces to any computer with USB. Here's the brain gauge here. Here are the cortical metrics that are generated with the use of the brain gauge. And CorticalMetrics LLC is the name of the company that supports the brain gauge technology and the software that obtains cortical metrics. And the company is primarily an R&D company that was spun out of the University of North Carolina by two faculty members. Those two faculty members were myself and Bob Dennis. And what does the brain gauge do? Well, the brain gauge does exactly what the computer tells it to do, and in our case, it delivers well-controlled pulses or vibrations to the fingertips. These pulses activate specific places in the brain. And let's go to the next slide. And when you see that two places or on the skin or the two fingertips are activated by the brain gauge, it activates two places in the brain that are side by side. And what that does is activate two places in the brain that talk to each other. And those two spots in the brain talk to each other in a very specific way, which has been studied for many years, and we have a very good idea about how those interactions are supposed to occur. And what we have done is we've developed specific tasks that relate to those specific functions in the brain. So let's look at it. And in this example, we're going to collect one cortical metric with the brain gauge, and that example is the amplitude discrimination task. And in the amplitude discrimination task, we deliver two stimuli, one stimuli to one finger, other stimuli to the other finger. And in those two cases, one stimulus is much larger than the other. And when you deliver those two stimuli to those two fingers, the subject or patient or individual is queried and they're asked which stimulus is larger. So not a very tough question, but the subject answers that the larger stimulus is larger. When they answer that the larger stimulus is larger, that means they got the question right. Each time they get the question right, the question gets a little tougher. So it's just like reading an eye chart. Every time you get the letter correct, you move on to the next letter or the next line, and it keeps getting harder. So in our case, this is tracked all the way down. The test gets harder and harder until the subject levels out and can't answer that question anymore. So you can tell from tracking down like this, just like on the eye chart, lower numbers are better, larger numbers are worse. And over here, we have it graphically shown that healthy controls do better than individuals who suffer from migraine or from concussion. Basically, when there's something wrong, that test actually gets worse. So, can we hypothesize about what's going on in the brain? So let's slide. And in this slide, we're looking at the relationship of the cortical metric with what's going on in the brain. Now, if you look at this section, you'll notice that there are two X marks depicting where we stimulated the brain. And this is in the brain of a rat. And you can see that there's two distinct areas of activation. You can tell both by the image where it's dark, and you can tell by the graph, the analysis of that image that shows it's very distinct. Now, if you add just a little bit of drug to simulate some different neurological problems, like we did over here, you see that now delivering those same two stimuli makes it much more difficult to tell the difference between the two. So compare the graph on the left to the graph on the right, you'd have a much more difficult time telling the difference between those two places in the brain than you did before. So that's the basic concept. Now that we have the concept down, and we want to look at what do we do with that one number, with the one number that we got in our amplitude discrimination task. And in this case, this is the pathway or the task that was used, tasked this part of the brain, and that contributes to our accuracy measures. Different measures contribute to different cortical metrics. So we have speed, accuracy, temporal order judgment, timing perception. All of these tasks, either different mechanisms or different pathways. They target different functions of the brain. And what that does is that gives us a chart. So if someone did very well on amplitude discrimination, their accuracy test would be very good. So let's look at some examples that different individuals look like. And in this case, we have very poor results here on all the cortical metrics from one individual. So they didn't do well on any. Then this individual did a little better and got mixed results. And then later, this individual did very good. And this was over a period of about a month. They got very good results. Well, if you could probably guess, this might be one way that some people would like to see if it works for treatment. And in this next slide, we have sample outcomes from 4 patients and 4 different clinicians. We have a pre-treatment is on the left, and we have the post-treatment graphs on the right. And without going into all the details about how the subject did or how the individuals did, you can get a general feeling, an intuitive feeling, that the graphs on the right reflect better results than the graphs on the left. So all of these patients improve from their different backgrounds and their different treatments at different clinicians. Basically, as I mentioned, we're an R&D company. We support a lot of research in a lot of different places, both clinical research and basic research, and we have many interests. One of our biggest interests is in neurotrauma, such as concussion and TBI. We also have done studies with neurodegenerative disorders, both chronic and acute pain, pharmacological insult, neurodevelopmental disorders, and cognitive states. And we've got many publications, and you can find all that on our website. And to learn more about us, I encourage you to go to the website or just email me directly and ask your question. Send your question to info@CorticalMetrics.com.